guys, welcome back. So we're looking at today's lesson 4, estimating probabilities through repeated experiments. So Mai plays a game in which she only wins if she rolls a 1 or a 2 with a standard number cube. List the outcomes in the sample space for rolling the number cube. Well, number cube has 1, 2, 3, 4, 5, and 6. What's the probability Mai will win the game? Explain your reasoning. So she only wins if she gets a 1 or a 2. So that's 2 out of 6. So that gives us a 1/3 chance. So that would be the probability she'd win. She'd have a 1/3 probability of winning. If Mai is given the option to flip a coin and win if it comes up heads, is that a better option for her to win? Well, flipping the coin would be a 50% chance. So 50% chance, or 1/2. So yes, better chance of winning. All right, so now we're not going to do this with a group, but I'm going to take and go through and do 10 rolls and list my outcomes, and then the number of times that she would win, and then show what that fraction of the win would be. So basically, I'm going to go through and do this, then we'll take and graph it. So I'll roll the number cube, we'll record the outcome, calculate the fraction of rolls that are a win, and approximate the fraction with a decimal value rounded to the hundredths place. So I'm going to go ahead and go do that. Resulting data from my various rolls. So first roll was a 2, so that means she won. But then rolls 2 through 9, none of them were a 2 or a 1 ever again. So her total wins stayed 1 all the way up until my last roll when she did get a 10 or get a 2. So fractions of the games played that are wins. So 1 out of 1, she had 100% winning rate. 1 out of 2, 50%. 1 out of 3, 0.3. 1 out of 4, 0.25, so on and so forth. But then when she won 2, we went back up to 0.2. So now we're going to take and graph this out. So at 1 roll, we were at 1. At 2 rolls, we were down at 50%. At 3 rolls, we were at 0.3 repeating. At 4 rolls, we were at 2.5. 5 rolls, we were at 0.2. 6 rolls, we were at 1.7. So right about there. 7 rolls, we were at 1.4 or 0.14. Sorry, cannot talk today. At 8 rolls, we were at 0.13. At 9, we were at 0.11. And at 10, we went back up to 0.2. So our graph is a curve that starts going back up. So I'm not going to try and connect those. I know it won't go well. But that's what our graph would look like. So what appears to be happening with the points on the graph? So points seem to be jumping less. So as the graph continues, the points get closer together. So points seem to be jumping less. So for 6, after 10 rolls, what fraction of the rolls were a win? That was 2/10. How close is this fraction to the probability Mai will win? So we had said her chances were a 1/3. Subtract the 2/10 from that, and we end up with 2/15. So a little bit off in our approximation. So now I'm going to go through and do it again to see a continuation of these results. New results, a lot more 1s and 2s in this. So we got up to 6 total wins for this. So a lot more wins. So we can see as we played the 2/11ths, the rate, our percentage of win went up, and we got back to our 0.33 or 1/3 chance, we went down a little bit to just 3/10, but we did go back up closer to that expected probability. So after 20 rolls, what fraction of the total rolls were a win? That would be 6/20. How close is this fraction to the probability that my will win? So we have 6/20. We thought it'd be 1/3, and then 1/3 minus 6/20 is going to give us 1/30. So it's very, very close to being what we're looking for, that actual expected probability. All right. For each situation, do you think the result is surprising or not? Is it impossible? Be prepared to explain your reasoning. You flip a coin once, it lands heads up. Is this surprising? So not really. There's a 50% chance of that happening. So not surprising. Yes. Possible. You flip the coin twice and it lands heads up both times. A little bit rare. Yes. Possible though. You flip a coin 100 times. It lands heads up all 100 times. Very surprising, because the chances of that are very slim. Yes, very surprising, but yes, possible. For 2, if you flip the coin 100 times, how many times would you expect the coin to land heads up? So we would expect it to be about 50 times, because there's a 50% chance of getting heads. So it's either heads or tails. If you flip the coin 100 times, what are some other results that would not be surprising? So anywhere from 40 to 60 wouldn't really be that surprising, because it's right around our 50% or 50 times. For 4, you flip the coin 3 times and it come up heads once. The cumulative fraction of heads is currently 1/3. If you flip the coin one more time, will it land heads up to make the cumulative fraction 2/4? Not necessarily. It could though. So 50% chance it could be tails. So we have what we expect it to be. There's 2 possible outcomes for flipping a coin. So we expect it to be 50%. But in reality, we don't always get heads, then tails, then heads, then tails. It doesn't work out that way all the time. So that's why we repeat an event to show we don't just do it one time and say, okay, yep, there we go. We do it repeated times to see what the chances are, and to get a more exact, or to get an answer closer to our expected. So repeated is your key word for this lesson, and the more times you repeat, the better off your experiment is. All right, if you guys have any questions, feel free to ask. Have a great day.